Hello, my friends. In this episode, we are going to work on continuous library. You can see here useful blocks such as derivative, integrator, integrator limited, integrator second order, integrator second order limited, PID controller, state space, transfer, form, and delay block, and zero pole, which is applied to show system. Here I won't explain state space, transfer function, and zero pole because I want to explain them in a separate episode, and I will show there how you can show a system with 4 different models. Here the derivative calculates time rate of input changes, which means dx on dt. The next and important block is integrator, as it is applied in most of the simulations. For example, this derivative block cannot be valid because this block is approximate of a derivative, and we often want to have numerical derivatives. As you saw, by double clicking on the block, we can see how does it work. Actually, the input is multiplied in the equation. For example, if we use Laplace, its derivative will become s, and the equation will be s division on c times 3 plus 1, which here we can define sc value. Its initial value is infinity, but you can change the value. Here the most applicated block is integrator. As always, by double clicking you can see its specifications. As you know, the yt, which is output of integrator, is equal to a y0, which is the initial value, in addition to time derivatives of x from t0 to t, which usually t0 is 0 and t is our intended time, which we enter here, which is per second. Well, here we want to show how to change the integrator block information and what is their applications. The first data that can be allocated to integrator is external result. It means that you can externally zero the integral value at any time and then start integrating again. In other words, you can reset it at any time. Here we can define them as rising, falling, either level to determine external reset. For example, here I set rising. As you can see, another input which is related to external reset added to my block. As you can see, the external word is here, and it says that we must enter this reset in the form of external to this block. Next is initial condition, which you can see, you can set it internal. Here we can enter initial condition of integrator. As you know, it is an important condition to our integrals. Also, you can set the condition as external, and you can see that in the external mode that value was deleted. If I click on apply, you will see that another input added to my integrator block 2. The first input is about the function which is going to be integrated. The second one is for external reset, and the third one is for initial condition of integrator. Also, here we can limit the output. We can set upper saturation limit and lower saturation limit. So we can activate saturation port. As you saw, another output added additionally we can show different states of integrator. Another output at the 2 here. We have absolute tolerance, which is about integration accuracy. I will talk about it in the last chapter. There are other options as reset when linearizing and enable zero crossing detection. I tried to talk about them in the last chapter, but remember that we usually accept these default values in blocks that previously find on MATLAB or Simulink. For example, maybe it will be need to define this upper saturation limit or lower saturation limit parts in integrator block, or maybe we need to set the initial condition on it. I think I have provided enough explanations about integrator block. Just pay attention that we have limited integrator, which is the saturation state. I explain it here. You can integrate from your fault 2 times about and limit it. Here, the other block which I want to explain is transform delay. Let's work on an example. If you double click on time delay, you can see its details. The most important part here is time delay part, which indicates the system delay. In this example, I want to have a sinus wave and show it with delay and without delay. I add mux to show both blocks. You can click on the block and move it using directions button on keyboard. I set the 2-second delay for sinus wave. Connect it here. For sinus wave, I just set the default values. Then I run the simulation to see the output. As you can see, the first wave, which is for sinus, starts from 0 second and is formed as a final sinus wave. For the second wave, which is for time delay state, the wave was started from the 2-second. Time delay block has this application, and you can apply it in your simulations and projects. Also, in continuous section, we have 2 other types of time delay, which are for variables. It means that you can set your delay time as a variable. Here, the first input is for the signal that you want to have time delay on it. The second input is related to the time delay, which is not internal. Here, I save this model too. The other block is here is, I think, transfer function. Here the point is that some students think that it can just deals with 1 divide on 1 plus s, but actually you can simulate any function. For example, I simulate this function. Now, as you can see, based on the entered value, my function has changed. Thanks for with us. Goodbye.